Hello students, today we are going to discuss the chapter number 5, that is signal generators and analyzers. So this chapter is there in the subject electronic measurements, and it is there for the 4th semester electronic instrumentation and control engineering. So myself Vijay Hugi, so lecturer in electronics and communication engineering department, SJP Trust Polytechnic Nitsoshi, and the various contents of these chapters are so the operation and the working of the signal generator, function generator, pulse and square wave generator, heterodyne wave analyzer and spectrum analyzer, and the applications of analyzers. Here the chapter starts with the working of signal generator, that is the block diagram of signal generator. So as we can see, there are so many blocks: the RF oscillator and amplifier, output attenuator, modulation oscillator. So basically a signal generator is an electronic device that generates repeating or non-repeating electronic signal either in analog form or digital form. So this instrument covers a frequency range from few hertz to many gigahertz. So it consists of two oscillators and one amplifier and an attenuator. So the RF oscillator consists of LC tank circuit. The RF oscillator produces frequency when we feed input supply to the tank circuit. So some of the advantages of signal generators are, so output voltage is generated is controlled and the output obtained is stable. And the various applications of signal generators are, so we can use in displaying electronic devices, designing electronic devices, and it is used in testing and troubleshooting electronic devices. So next we are going to learn the function generator. So as you can see in the diagram, there are the important blocks here. So that is frequency control network, and there is upper constant current source and a lower constant current source. There is an integrator, then voltage comparator, vibrator, resistance diode shaping circuit, output amplifier, then output amplifier 2. There are two output amplifiers, that is 1 and 2 here. So first I'll say the function generator is an instrument that has the capability of producing different types of waveforms with a frequency range of from 0.01 hertz to some hertz. So basically the function generator will produce a sine wave, square wave, triangular wave, etc. here. So as we can see in the block diagram, the function generator is it consists of what? A constant current source, integrator, a comparator, multivibrator, a shaping circuit, and amplifier, etc. So in this generator, the frequency is controlled by varying the magnitude of current. So that drives the integrator. The output of integrator is a triangular wave. So as we know, the integrator is going to produce a triangular wave here. The voltage comparator multivibrator produces the square and rectangular wave, whereas the output of the shaping circuit is the sine wave. So the function generator has two output waveforms, output amplifiers that provides two simultaneous output waveforms. So any two waveforms, that is sine and triangular or sine and square, etc. here. So as we can see at the output, we can generate so many different waveforms here, like square wave, we can generate triangular wave or sine wave here. And next we are going to see the applications of function generator. So it is used to generate sine, square, triangular and sawtooth waveform. So next it is used to display two output signals, and third it acts as a source for the alignment of receivers, and it is used as a signal source to test amplifiers. Then it is used to introduce an error signal into a closed loop, and even working with analog circuit, and it is used as a signal source to test amplifiers here. So next we are going to discuss pulse and square wave generator. Basically it consists of the two current source block, the frequency control, the switching circuit, the ramp capacitor, the skimming trigger and output amplifiers, etc. The upper current source supplies a constant current to ramp capacitor. So this charges the capacitor at constant rate. So when capacitor charges to peak, it starts discharging with linear rate controlled by lower current source. So the entire process is repetitive. So schema trigger provides a negative pulse at a continuous rate. So next we are going to discuss heterodyne wave analyzer. Before that, we are going to define what do you mean by wave analyzer. So basically it is a voltmeter which can be accurately tuned to measure the amplitude of a signal. And next we are going to learn what do you mean by heterodyne wave analyzer. So the blocks of heterodyne wave analyzers are the input attenuator, and there is a mixer, then oscillator, then fixed frequency active filter, then detector, then the output meter here. So the input signal to be analyzed is heterodyne to higher intermediate frequency by an internal local oscillator. So tuning the local oscillator shifts various signal frequency components into the passband of IF amplifier. Then the output of IF amplifier is rectified and is applied to the metering circuit. The operating frequency range of this instrument is from 10 kilohertz to 18 megahertz. The bandwidth is controlled by an active filter and can be selected at 200,000 and 3000 hertz. So the various applications of wave analyzers are: it is used in electronic equipments, it is used in sound measurements, it is used in vibration measurements. So it is used in industries to check sound and vibrations generated by rotating electrical machines and apparatus. So it can be reduced or eliminated. Then it is used to measure amplitude in the presence of noise. So next we are going to discuss the spectrum analyzer. So it is defined as it sweeps the signal frequency band and displays a waveform of amplitude versus frequency. So as we can see here, there are so many blocks. The RF input is given to the mixer, and there will be a IF amplifier, then detector and video amplifier, the output of which is given to the wide deflection plates of the CRO, and below that there is a voltage tuned local oscillator, a sawtooth generator. In turn it is given to the X deflection plates of the CRO. So the spectrum analyzer, it provides a calibrated graphical display on its CRT with frequency on horizontal axis and voltage on vertical axis. So its figure consists of various blocks, as I told already: sawtooth generator, local oscillator, so mixer, IF amplifier, detector, and display. The sawtooth generator generates a sawtooth signal which is fed to the local oscillator. Output of local oscillator and input signal are heterodyne, means they are mixed in the mixer to produce intermediate frequency. So these intermediate frequency is amplified, detected by the detector and displayed on CRT. And let us discuss the various applications of spectrum analyzer. So it is used for antenna pattern measurement, and it is used in FM, AM, then pulse modulation to measure various parameters. It is used to measure harmonic distortion. So it is used for FM deviation measurement, and it is used for tuning parametric amplifiers here. Thank you.